Literally what it means is if you take an absolute value of the inside and then investigate and it still converges, then it's absolutely convergent.
That's all you need to do to prove it.
Yep. If I
And
say
if it
test,
doesn't, then it's
if I said, here, test for absolute convergence. Test the abs of this series. Be quiet. What's my first step? Take the absolute value. So this just becomes what? Trying to be 1 over. Then you would apply what? You could either do
the test.
limit comparison, is what I would do. Yes? Are you guys understanding? You literally just erase this shit. Because if I take the absolute value, every term is going to be positive, not just every other term, yes? And you guys just told me, is everybody cool? Can I just say this is going to be 1 over n, so you can do limit comparison? Is everybody with me? Yes? So this is going to do what? Diverge.
So
Then
it's
I would go
conditional.
back. So my suggestion to you is you check absolute convergence first. Because if it absolutely converges, you're done. If it doesn't absolutely converge, then you go back and see if it conditionally converges. You with me? What do you guys think? Will it conditionally converge? What 2 things does that have to do? The limit has to be. The limit has to be 0. Is the limit of that going to be 0? Of course it will, yes? Because the bottom's a higher degree, yes? Will it be decreasing? Yes. Right? You can take a derivative to prove it, but you guys agree with me that as the bottom gets bigger, the whole thing's going to get smaller. So it will be decreasing. You could show it by taking the derivative. Yes? So this series, is it conditionally convergent or is it absolutely convergent? It's conditionally convergent, yes. Based on the condition that you let the negative stay in. Or little dude, yes.
Okay, so absolute convergence is just taking the absolute value.
And then seeing if that
it
resultant thing
converges.
converges, yes.
But for conditionally convergent, it's not just like,
It's just testing the original thing. Don't take the absolute value.
okay, so like for this one, it would be you just go back and you do the,
Yeah, since this didn't
the
work,
alternating series.
since this didn't work, I go back and do alternating series tests.
But if that was like
If
a
that
series
worked-
or something,
Yeah, whatever
Then-
it is.
okay.
Yeah. You guys gonna be?
so those aren't the.
If this
conditions
worked,
that you
I'm
want.
done. Because I know if it's absolutely convergent, it must be conditionally convergent, yes? Does that really make sense? If I add a bunch of positive numbers and they stay finite, what should happen if I make every other number negative then? That should be even less. That should be even more finite, yes? Should be even further from going to infinity. Does that make sense? Okay. Yes?
Because you're just like the way you just explained it, because if you add, if every other one is negative, then it's like taking less of a step each time.
Yeah, so, man, you really didn't bring much paper, Jeff. There you go. Good, yeah. So, 1 over n, what does that do?
Divergence.
Diverges. Because 1 plus 1/2 plus 1/3 plus 1/4. That looks to us like it gets small quick, but it doesn't get small fast enough. It doesn't get small enough fast enough, does it? This will diverge. Knife's edge. So if I compare that to this, that's what's happening. Shouldn't that second one converge then? This guy almost converged. This guy's gonna definitely freaking converge. It's like I'm going down. No, I'm not. Yes, I am. No, I'm not. So it's never gonna be able to like go to infinity because every other time it's taken away from itself. Yes? It's doing this kind of thing. It's like, it's not going to be able to blow up. That's what happens with every series. If you leave, now be careful. Be careful how I say this. That's the idea behind leaving the negative one in. Now, obviously, if it doesn't meet the two requirements, it won't even conditionally converge, because we've seen ones that just diverge. Yes. So if I had something like this. Why should you do very little? Yeah, if you do the test for divergence, you're done, correct? So what fact that I told you guys stays constant no matter what? You can always try the test for divergence first, right? Because there are several things that need the limit to be zero, and if it isn't zero, I'm immediately done. And this limit would be one. Infinity, because the top degree is higher, yes? So it's not, is it conditionally convergent? No. Is it, no, it's not convergent at all. So it's no adjective convergence, yes? It is just straight up, no adjective required, divergent. Or you can say freaking divergent if you want to. Okay, how are we doing there? I really need that to make sense. For the very first time we started talking about sequences and series, if I add a bunch of numbers together, it's weird that sometimes it will say finite, but now we're really used to that. We've seen a bunch of things that remain finite. If I let every other number be negative, it should be easier for it to converge. Yes?
Do you have an example for like a function that would be always decreasing but also an actual limit that's equal to 0?
Oh, sure, yeah. Let me see, hold on. Oh, sure, yeah, okay. Duh, me, I'm smart. There. One plus one is 2, 1 plus 1/2 is 1.5, so every time isn't the sum getting smaller?
Yeah.
I'm sorry, is the sequence elements of that series getting smaller?
Yeah.
But they're approaching.
Yeah.
What are they approaching?
Oh, it's approaching 1.
1, yeah, there you go.
Okay.
That's all I have to do. And real quick, do you guys, this kind of thing is kind of silly. Do you see how there's two series? One of them is this one, and then it doesn't matter what the other one is really, unless the other one was like -1, but even if I did this, does this converge? Because what does this do? If you add 1 forever, 1 plus 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 forever, it's going to be. So I don't give a shit that this guy gets small really fast. This guy screws him over, yes? It's like he's over here going, I'm getting small. And then he looks over like, oh, shit. This guy's going freaking infinite. What the hell can I do?
Yeah.
All right. So that's a good point. That is an example. So if I did this, that's AST, yes? It is decreasing. You take a derivative. What's the derivative of 1 plus 1 over x squared? You can do it. Derivative of 1 is? Derivative of x to the -2. And that is less than 0, yes? It's negative. You can see it. It says so. Because x is always positive because it starts at 1, yes? Is that cool? What's the other condition for AST? Limit. And if I take the limit as n goes to infinity of 1 plus 1 over n squared, what's 1 over n squared do? So the limit of this is 1. So why does that not converge? Because this is not. So be very careful. Don't just stop at 1. Because then I'll say something like, I'll have to be a dork then. You have forced me to be a dork. I will say, oh, so if it's equal to 1, that's what you're checking. If it was equal to 0.9, it would have been great. No, it's the fact that I got a number that wasn't 0. You have to show that to me. So that I know you know what you're looking for. Is that okay? That's a really good question. I love that shit. Anytime you have these theorems that are like, these two things have to work, and you're like, how could only one of those not work? That's a beautiful question to ask. Yeah.
So, with the example before that, the one that you did where where the absolute one was divergent, or where the absolute one was convergent, but the other one was divergent?
No,
Is
it
that-
can't happen. That can't happen.
Okay.
If it is absolutely convergent, it definitely is conditionally convergent.
Okay.
Right? In fact, we wouldn't even say conditional because that would mean it's only convergent. So what I mean is, if it's absolutely convergent, it will definitely still converge if I leave the negative one in.
Okay. So if you do the thing for absolute convergence
And it
and
doesn't
it's
work,
convergent,
Oh.
then it just is.
then you're done.
Okay.
It's absolutely convergent, I'm done. If you do that and it doesn't work, then you worry about checking for conditional. So that's why, in general, it's kind of silly to do conditional first, because that's going to work a lot of the time. And then you still have to do absolute. And if you would have just started with absolute, sometimes that's all you have to do. Does that make any sense? And if you want to, you can always do both. I don't know. You want to be crazy. But if I were you, I would check absolute first, and then if that works, I'm done. If it doesn't, I'm like, okay, gotta do more shit. Okay. Maybe. Okay. Is that okay by itself? The idea of absolute convergence versus, that's gonna become really, really, really big right now. So we're getting into 11.6 officially. Can you guys remind me, what is up with this dude here? Okay, I didn't mean for this to be tricky. This should be easy as shit. Easy as shit, not a trick.
It's a geometric.
Geometric. What do you know about it? R is
R is 2/7.
in your face, yes, which is,
Less than 1.
so therefore it is
Convergent.
convergent. If I gave you a series like this instead, is everybody cool with all this shit? Just want to remind you guys, geometric. You could then do a over 1 minus r, figure out what it adds to be. There's very few series that we have a closed form for the sum. When I say closed form, does that make sense? Like, that's open. That's an infinite sum. The series never stops. The terms never stop. A over 1 minus r, closed. I can get a number, correct? Most series out in the wild, I can't do that shit with. There's a ton of them we can, though, and we're going to learn about them later in this chapter. Not quite yet. What if I gave you something like this? What, Jeff? Write something. There you go, buddy. You're doing it. I kind of give myself shit. What do you want to do here, buddy? There you go. You're doing some more stuff. Look at you go. Shit, why'd you do that? Okay. Oh, that's right. I want to do this. That's right.
Is that E6 or is it
On the bottom?
E?
I was kind of hoping that was really obviously 80. But I don't, okay, you're okay. I'm sorry, I just write really horrible, so when I write okay, I think, oh, look at me go. Oh, shit. How can you check this if it's geometric? How do you check to see if it's geometric? Yeah, it's like, what's 18 divided by 3? Because what's the idea of geometric? Real quick, what's the idea of geometric series? I keep multiplying by the same thing to get the next term, yes? So obviously, how can I check to see if something's geometric? I just take a term and divide by the one before it. And then I can check to see if I multiply by the same thing, right? So 18 divided by 3 is 6. 20 divided by 5 is 4. So it looks like maybe it's 3 halves. So what do I get when I multiply 18 by 6? Hopefully I get this. Thank the gods. And then if I multiply this by 4, yeah. Is everybody with me? And we've seen it both ways, yes? So what does that series do? Divergence, yes. And you can, now real quick, this kind of leads into something else I wanted to show an example of. What was it? Oh, shoot. Yes, there it is. A little side note. Is everybody cool with this? So that's one way I can give you a geometric series. Here's another way. What we're going to do in 11.6 is we're going to look at things that are not quite geometric. Where we're going to develop a test that I can get the answer nice. It's going to be too nice to believe, is what I hope. Before I forget, though, can you guys all help me? Let's see. I should have tried some of this out before I did this. Can somebody help me? Do y'all see this natural log of n? It's trying to be natural log, but it kind of melded together. Can you somebody put a 2 in there? What do you get? Like, put it in your calculator. Here, I'll do it with you. Let's see if this does what I want it to. Damn it, you didn't bring a calculator, Jeff. Hopefully you guys all wrote that down. What'd you guys get? What'd you get? Sorry? Yeah, it should be, huh?
0.364.
That sounds reasonable. Let's see. Oh, Jeff, you don't want this. You want this. Oh, was this going to let me do it? Let's see. Oh, well, screw you so much. Okay. We're going to be okay, everybody. Google. Okay. TI-84 emulator. Okay, give it to me. Give it to me, baby. There we go. All right. Two. By the way, do you see what I just did? Google's your friend. So if I do, where'd it go? Natural log of 2. What was it? Divided by 2 to the, oh, it's up there, Jeff. 13 divided by 14. You get this. Now here, let me show you something. This is kind of cool. I want to do 3 next. So I'm going to store 3 in x. And then I'm going to do natural log of it divided by it to the 13/14. Enter. Do you see how that's increasing so far? Yes? And I'm going to take 4, I'm going to store it in x, and then I'm going to do this. Come here! Now it starts to decrease, yes? So that's a horrible decision. I should have done some first. There are functions that will, it's not a good example. There are functions that if you do the first 800, they're decreasing. But then at 800, they start to increase. Do you guys understand what I'm saying? So many of you did the first few elements and tried to say something general. You cannot do that. You can't. Because you've seen shit do this. You graphed a ton of functions in your career, and you've seen functions do all kinds of, I'm decreasing, no, I'm not. Right? So I cannot look at just a few elements of a series and determine what it's doing. I can't. Because maybe at the 8 billionth one, it starts to go up forever. Yes? Maybe? No? All right. Go away. Let me go back here. Okay, so coming back to this idea. Geometric says R has to be less than, R has to be less than 1. I'll put the absolute values right. Because that could be multiplied by a negative number. As long as that's absolute value that's less than 1, I'm golden. What happens if R equals 1? What kind of series would that be then? True, but if R equals 1, what do I keep multiplying by?
1.
1. So it's just a series with the same element over and over. It's going to add that to itself forever. Yes? You guys kind of with me? Okay, that's why it's got to be strictly less than 1. That'll make it shrink fast enough so it will converge. So what about something like we have on the test? Let me start off with something kind of nice, and then we'll get freaky. What about, actually, let me do one like this. What about this here? What you got, Jeff? I don't know. Oh my God, my brain just turned off. There it is. Is that geometric? Let me say it like this. Is that almost geometric?
Yes.
What's it? What do I keep trying to multiply by? I keep trying to multiply by 1/4. Yes. What part of this is not playing around with that? What part of this is not okay with that? The top. The top is slowly growing. Correct. Do you all agree with me though? Here, watch this. So the top here would be n, and the bottom would be 4 to the n. Is that cool? So that should look very familiar to some of you guys. So help me out. What is the what's the 10th term? 10 over 4 to the 10th. Yes? And what is the 11th term? 11 over 4 to the 11th. Yes? Now, real quick, remind me. How did we determine what R was for the thing I can't find anymore? Damn it all. The series I wrote out step by step earlier. Like, how did you figure out this is like 1/4? Where you take 1 divided by the one before it. If you ignore the top, it's trying to be R equals 1/4, yes? So what if I divide this term by that term? What will I get? I'll get, let's try that, 11 divided by 4 to 11 times the reciprocal. Is that okay? If I divide this one by the one before it, yes? That's how I can figure out what R is. What do I get? How many 4s cancel? 10 of them, yes? So how many are left? Where? Yes, okay. I'll calm down. What is 11 divided by 10 almost? 1. So isn't this, can you imagine if I let this go to 100, you could do it, Jeff, then it would really be close to 1/4. I mean, this is already almost 1/4. Are you with me? So on one level, this seems to be really close to a geometric series. Is it a geometric series? No. So can I just say R is 1/4? Of course I cannot, because that's not true. If I let n get big, and in fact, what's the whole point of a series? Letting n get big. Doesn't it become essentially multiplied by 1/4? I really want this to make nothing but sense. When I go out to the 10th and 11th term, it's 11 over 10 times 1/4. If I go out to the 100th term, it would be 101 divided by 100. That's really close to 1, yes? If I go out to the billionth term, it's 1,000,001 divided by 1,000,000,000. That's basically 1 for most of us, yes? Does that make, so in the long run, this does become geometric. So we need a formal way of showing that. So here's how we do it. If I just gave you a sequence like this, what would the next term be? Here's a sequence element, yes? What's the next term? an plus 1, yes? And if I thought this might be geometric, how do I determine what R is? Divide what by what?
N plus 1.
Yeah, divide 1 by the one before it, yes? Because then I can see what somebody multiplied by. Now, what did I just say earlier? I want to see if I let n get really big, does this basically become like an R? Does this basically become a number? Maybe like 1/4 or something, right? So how does that work? How do I let n get really big? I take a what? Limit. And what was the check for geometric? What was the full official check for geometric? What do I check? Not just r, but the... Yes, so I'm going to check that. So if I'm given a series, and to be really honest, this will work for a ton of series. If I have no idea what the hell to do, or if the thing says, now what do you think we call this test? Didn't we just set up a ratio of two elements? So again, math people continues to prove to you how creative we are. We said,
Let's call it the ratio test,
so we did, we called it the ratio test.
because it's a test when we make a ratio.
Okay. So this is officially the ratio test. And what it says is, if in the long term this becomes a number, and that number is less than 1, it effectively is a geometric series, or close enough, and it will converge. Now, to be really, and this is kind of silly, I took an absolute value, correct? So what is the lowest this could be?
0.
No, I took an absolute value. So the lowest it could be is 0. So this is really 0 less than or equal to L less than 1, but that's inherent in the absolute value. Are you guys kind of with me? So if I get 0, if in the long, all right, let's try one out that actually that happens. Here. Well, let's try this on the one we just did first. So I want to do this. So what is AN? Don't overthink it. What is AN? N over 4 to the n. Yes? It is what is inside the series, yes? What is AN plus 1?
1.
Kick ass. Now, very quickly. In AN, how many 4s are on the bottom? Nope. N. Right? Goes 4 squared. There'd be 2 4s multiplying. Somebody say it later. I'm sorry. In AN, how many 4s are multiplying? N. In BN, I'm sorry. In AN plus 1, how many 4s are on the bottom? Multiplying. N plus 1. Yes? So which one has an extra 4? Okay. Right? Okay. So watch how this is going to work. So how do I apply the ratio test? And again, I really want you to understand. This one we saw directly. It was trying to be geometric. You don't have to know ahead of time to apply this test if it's trying to be geometric or not, because this works no matter what the shit. If you get an L less than 1, then you're like, oh, it was trying to be geometric, and I had no way to know that shit, but now I know. And then you know it converges, yes? If it's greater than 1, it diverges. Now, what do you think happens if it's equal to 1? No, it's inconclusive. Inconceivable. Then it's inconclusive. Yes. Okay. I have a handout, believe it or not. But I think I put it, yeah, I do. So, let's try this. You ready? So, to apply the ratio test, I take the limit as n goes to infinity of the absolute value. Now, we've seen this already. Most of the shit we look at are already fractional, yes? So most of the time, what we're going to do is we're going to write the top dude, and instead of making this big-ass fraction, we're just going to multiply by the reciprocal of the guy that has you in the bottom, because that's how the freak division works, yes? Divided by something is multiplied by this reciprocal. There is no division, basically. There is no division. Now, is there a part of that limit that relates to something we talked about earlier that had 3 possibilities? You see the parts that are just purely polynomial. Do you know what the limit of this is? What's the limit of n plus 1 over n? This goes to 1. Kick ass. I'm taking a limit. N plus 1 over n goes to 1. Now, what did you guys tell me earlier? This is where people get all really trippy. Let me show you how this really works. When do I add powers? When you're multiplying. So how can I rewrite 4 to the n plus 1? 4 to the n times 4. There. So what cancels? Now, do you really have to do that? No, you can just go, that has n plus 1 fours, that has n fours. N fours cancel, I have 1 left. Why am I spending so much time on that? Because it's going to happen a lot. So what is this? What am I left with then? Which is what we got earlier. And 1/4 does what? It is less than 1. Therefore, the series, like Stephanie said, the series converges. This number we get is the effective R. If I let n get big enough, that is effectively what the multiplier is. Bless you. And as long as the multiplier is less than 1, we learned that from geometric, it's going to converge. Yes, beautiful. Thank you. I always forget to say that. Since we took an absolute value to get here, it is officially absolutely convergent. Because technically it could have started with a -1 power. To do the ratio test, I take an absolute value. So it's always, at the end here, it's absolutely convergent. Okay. So let's try another one. What is the weirdest thing that you have to work with in a series? What's the weirdest, function? You can do it. There's one problem that we said earlier that was
Factorial.
Yes, there we go, okay. Let's do it. What do you got, Jeff? I don't know, Jeff. 2 to the n over n plus 3 factorial. Dear God, I don't want to do anything. I don't want to do any test we talked about before what we talked about today. But do you see how this is beautiful for ratio tests? Somebody remind me what the hell n plus 3 factorial is? Well, first off, real quick, what's 7 factorial? 7 times 6 times, so what's n plus 3 factorial? N plus 3 times n plus 2 times n plus 1. And what can I do if I get tired and somebody says, what's 7 factorial? I go 7 times 6 times 5, I'm tired. Yes? That means the same shit. Why would I maybe want to do that? Because maybe that's somewhere else that I can kill it. Factorial just means, oh, you got to keep going, but whoever wrote me got tired. Yes? Not the technical definition, but that's going to come into play. Can you guys take a moment and set up ratio tests for this? Set up what the ratio test will look like. While you're doing that, I'm going to give you this. This is a little pop quiz. I'm joking. Let me catch up to you guys. So pretty much the shortcut for these is you rewrite this, but you replace n with n plus 1, right? And then you multiply by this guy's reciprocal, yes? That's the shortcut for setting that up. How do these work? How many 2's cancel? No.
N
And 2's cancel. How many's left?
1
Where?
on the bottom.
No.
Top.
On the top, because that's where more work. How do the factorials work? Which one has more?
The bottom.
So I can start to rewrite them until I see the other dude. Yes, I'm gonna see that one pretty damn
So
quick.
you just have N plus 4 1.
Yeah, so let's see it in action. If I start to rewrite n plus 4 factorial, n plus 4 times n plus 3. Oh, sweet. These kill each other. Yes? That's so beautiful. I mean, do you understand? Is there any factorial left? Factorial's gone. Ratio test kicks ass. What's the limit of what's left? 0. Does that do what it's supposed to do? 0 is less than 1.
Yes.
So the check for ratio test is the result has to be less than 1. Why does that make sense? Because it's basically geometric. It's trying to find a geometric series in the mesh you're working with. So this is an example of a function where the elements get so stupid small that eventually it's basically multiplying by 0. So let me see what your calculator can handle. Oh, by the way, I don't know if I've ever pointed this out to you guys. Do you know where your factorial button is?
Yes.
Where is it, Sarah?
Isn't it in math?
Yes, it's in the math. I think maybe I did show it to you. In the probability, right there. So, if I want to do, let n be 100, let's say. So 2 to the 100th power divided by, where'd it go? 103 math probability number 4. See if we can do it. No, damn it. Too big, too big, too big. Hold on. Let's ease up on our. Let's go 50. So that will make this 53. Is that cool? Let's see if that overflows. Okay, good. Can you guys all see that? It's kind of tiny. I'm sorry. Okay. What does that mean?
That it's basically 0.
1, 54 zeros. Yes? Most humans would call this what?
0.
Freaking 0. So that's what this means. The numbers get so damn small that effectively, what am I multiplying by? 0. Because the next number is going to be smaller than this, and this one we already said was basically 0. Yes? So that's kind of weird. It's not really R is 0, because otherwise then every element would be exactly 0. But it's effectively 0 in the long run. Maybe? All right. So if you look on this, what I just gave you, this is especially good when you have exponentials and factorials. Yes?
Sorry, this question just came into my head. So if it's inconclusive, does that mean that we just have to
Have to
Use a
apply a
different-
different test.
use a different test?
And you just hope to God a different test might work. Yes. So last thing for today. Let's try the freakiest one on there. Let's look at number 3. Real quick, just real quick word. Look at number 2. Do I have to apply the ratio test, or can you guys see what's going on there? R, by the way, just to save you, R is not 2 7s. Hell no. It's 8 7s. Kick ass, because it's cubed to the end. So it's 8 7s, and therefore this thing would diverge. This is a question, yes?
So then could you rewrite it as 2 cubed over 7 all to the
To the nth power, yes. Because what do I do when I raise something with a power to a power?
You multiply
Multiply. So this 2 to the 3n is 2 to the 3
times that.
to the n. So it's 8 to the n. Okay. Now this would be actually really easy with AST because the limit of this is not 0. Because the top is bigger, it's going to go to infinity. All right, enough of that. So this one's the freakiest one on here, I think. What do you guys think? What I want you to do is take a minute and write what is n plus 1. I already know what an is. It's staring me in the face. What is an plus 1? I'll give you a little hint. The bottom is not going to be 2n plus 1. That doesn't make any sense. So is this cool? I replace n with n plus 1 on the top, yes? Oops. Make another little factorial. Okay. So what's the bottom going to be? Yeah, so you have to replace n with n plus 1. Kick ass. Yes? Do you see that? So don't just put a plus 1 next to what's there. Replace n with n plus 1. Because how would you figure out a7? You would replace n with 7. So how do you figure out a n plus 1? You replace n with n plus 1. So let's simplify this a little bit. This will be top I can't really do much with, but I will do one thing. Well, not yet. I'll leave it like this. On the bottom, all I can really do is this. Okay, so then if I set up my ratio test, it'll be this thing. Here, I'll do this. That's what n plus 1 factorial squared is, yes? All over 2n plus 2 factorial times 2n factorial over n factorial n factorial. So if I'm you right now, I'm going, what the shit, man? Factorials are bad enough, and then you square the damn things, but that's all you have to do. Write it twice. Does this make enough sense? Can you see what to do with, like, do you see how these kind of go together? How can I make these show up here so they can cancel? I just have to, for each one of these, do what? Start to rewrite them so that, yeah. The way I look at it is, I'm the king of not enough room. Okay. I take out the first term. So I'm going to do it for each one, yes? And then what am I left with? So n plus 1 factorial will be n plus 1 times n minus 1, but I don't want to write all that shit because I got tired here, so I just say this, yes? So let's just focus on that for now. Don't worry about the 2 shit yet. So here, look at that. Look at that. Ratio just eats this shit up. What's the worst thing about factorial? It goes on forever, because I don't know, n could be whatever. So this ratio test lets me kill an infinite number of things. It's very satisfying. So what can it do with this? Same thing. What's 2n plus 2 factorial? I'll get it started. 2n plus 2 times 2n plus 1. Good, because the definition of factorial is you take it down by 1 as you multiply. Times? I'm tired. It's more than I'm tired. It's that is where that matches. So then this whole thing can just die. If I were to multiply the top out, what would the highest degree be? If I were to multiply the bottom out, what would the highest degree be? So the limit would be the ratio of the coefficients. So you guys, without multiplying that shit out, can you see the top would have a coefficient of 1? What would the bottom have? A coefficient of 4. And what does that do? Does that do what it's supposed to? Yes. That is less than 1. Converges. Absolutely. So now you're going to look at punctuation very differently. I'm sorry.
You take out a letter every time.
Yeah, exactly. So is z factorial z times y times, I don't know. Okay. Is that okay?
Yeah.
So personally, this feels very gratifying. I'm hoping, is what I would expect. But you get to just kill the stuff that you really is weird to work with. It just dies. It just melts. This, by the way, is probably one of the more important things we learn because it's used in a lot of different ways in a few different chapters. So we'll talk about this next time. This is very similar to this. It's not used very much, but yeah. All right, guys. Did anybody not get their test back? Everybody? Oh.